Welcome back to our Math 171 video series. For this set of videos, we'll do more practice on more complicated logarithmic and exponential equations. Our first logarithmic equation says log of x squared plus 3x is equal to 1. To solve this equation, we're going to get the log by itself and then take the proper exponential to clear that log. We may notice that this log is already by itself on the left, and this log has no base written by it. If you have no base written for the log, it is automatically base 10. That means the exponential that we take must also be base 10. So on the left and right, we will write base 10, place an equal sign in between them. Then everything from the left side we'll move to the exponent on the left. We'll have 10 raised to the log of x squared plus 3x. On the right, we'll start with a 1, make that our new exponent, and we'll have 10 to the first on the right. Now, recall that base 10 and the common log are inverse functions. And where we find inverse functions, we cancel them out. The base 10 and the log will cancel, and we'll be left with just the exponent, which is x squared plus 3x. On the right, we'll still have equals 10. Note that what we have now is a second power equation, and for a second power equation, we'll move everything to the left and try to factor. We're going to subtract 10 from both sides now. If we subtract, we'll end up with 0 on the right, and on the left we'll have x squared plus 3x minus 10. We can then factor this. Let's think of two numbers that multiply to negative 10. We could try negative 5 and positive 2. Multiplied, those would make negative 10, but when we add it, we'll get negative 3. That's the right number, but not the right sign. We want positive 3 instead, so we invert the signs and we'll say positive 5 and negative 2. If we add those together, those will make positive 3, and that's a match. Therefore, our parentheses will be x plus 5, x minus 2. If we solve each piece, the first piece will give us x equals negative 5, and the other piece will give us x equals 2. It's not enough, however, to get those solutions. We must verify that neither one of them makes the log term become negative, because inside of a log, the contents must be greater than 0 strictly. We're going to plug each of our solutions into the log term and check to see if it's greater than 0. Therefore, we'll first let x equal negative 5. We'll assert that x squared plus 3x is greater than 0. If we plug in the negative 5, we'll have negative 5 to the second power plus 3 times negative 5. Negative 5 squared is 25, and 3 times negative 5 is negative 15. 25 minus 15 gives us positive 10, which is greater than 0. Therefore, this statement is true, and x equals negative 5 is a true solution. We'll check again now with x equals 2. Once again, we'll start by asserting that the contents of the log are greater than 0. We'll let x become 2, so we'll have 2 squared plus 3 times 2 is greater than 0. 2 squared is 4, and 3 times 2 is 6. We'll set that greater than 0. 4 plus 6 is 10. That's greater than 0, and so this other statement is also true. Therefore, x equals negative 5 and x equals 2 are both solutions to this log equation.